So, with a linear function, the average rate of change is constant. That means if I gave you a problem, an average rate of change problem, and the equation was y equals 4x minus 6, it would not matter what interval I gave you, you would always get an average rate of change of 4. All right. And that's the slope of the line. What you're going to be doing is looking at a table to determine if the table is giving you a linear function or not. So, here's what you do at a table. If the x values increase by the same amount, then you're like, cha-ching, easy peasy. So, if you have x values that go up by the same, it doesn't have to be 1, 2, 3, 4. It could be 1, 3, 5, 7. Then you're going to look at the y values. If the y values increase or decrease, they add or subtract the same number, then it's linear. Okay? So if your x's and your y, like your x's increase by the same amount, they might increase by 2. Your y values might increase by 7. But if it's plus 7, plus 7, plus 7, plus 7, it's linear. Okay? It's when the x values do not increase by the same amount, you have to calculate the rate of change to see if the rate of change is the same all the way throughout. So with linear functions, when you're going to see a table, okay, you're going to see if they increase by the same amount all the way across. So, let's look at number 1. Do my x's increase by the same amount? No, I gave you a hard one to start out with. So, what we have to do is we're going to calculate the average rate of change 3 times to see if that average rate of change is the same. So, with average rate of change, what do we subtract on the top? The y's. So negative 5 minus 1 over 1 minus 4. You will be expected to do this without a calculator. So negative 5 minus 1 is over, which is 2. All right. And then let's do it again. 1 minus 3 over 4 minus 5. One minus 3 is negative 2. 4 minus 5. That simplifies to 2. So far, so good. Don't stop until you've checked every interval in your table. Okay. Now, if I got 2 different numbers, then I could stop because it would be no. But 3 minus 7 over 5 minus 7. Negative 4 over negative 2 is 2. So, is my average rate of change constant? Yes. I got the same number for the average rate of change all the way throughout. So, yes, it is linear. Now, when you see these on multiple choice, it might say, yes, it is linear because. Then part B might say, yes, it is linear because. And then C and D would be no, because, no, because. So not only do you have to know that, yes, it's linear, you have to know the right reasoning. And there's a couple different reasonings that you might see. For linear, it's typically going to be because the rate of change is constant. There's another one that I will write on another example. Okay, so you kind of see both of those. But you need to know that linear and rate of change is constant. Those go together. All right, so let's try number 2. Do my x's increase by the same amount? Yes, so I don't have to do this whole formula. You can, but you don't have to. So what you can just do is say like, okay, 6 to 8. How do I get from 6 to 8?
Plus 2.
To get from 6 to 8 is plus 2, yeah. 8 to 11? 3. 11 to 15? 4. So, are those numbers constant all the way across? Did I write the same number all the way down? No. So this one is no, it is not linear because you can say that the average rate of change is not constant. Sometimes we refer to this as the first difference. So when you do your table and you find those differences the first time, we call that the first difference. We're going to do it with quadratic and we're going to look at the second difference. Okay? So you can say because the first difference is not constant. Using the first difference, using the rate of change, either of those is okay in an explanation to me. You just might see both of them on multiple choice. Now, number 1, you really probably wouldn't use the first difference because if you truly found the first difference, they wouldn't be the same all the way across because your x's aren't the same. Some other vocab that I want to add in here. It's just going to be a phrase, and it's a really wordy phrase, but it means that the x values go up by the same number. So x values go up by the same number. I'm going to tell you the funky phrase that you're going to see a lot in wording. It's going to say over, what is it, equal length input values. When you see that, equal length input values, that just, input values are your x's. That just means that your x's go up by the same number. They just have to be all fancy. So, with pre-cal, the good thing about it is that you see the same wording, the same types of questions over and over. Some of them are difficult, yes. But I'm learning with calculus, like, it's not that way. There's such a huge array of questions and stuff. With pre-cal, it's a little bit narrowed down, which is going to help you when it comes time for the test. All right. So, let's talk about quadratic functions. If you have a quadratic function, and I give you intervals, and I say, find the average rate of change, it's not going to be the same every time. Okay? So, quadratic functions have a constant second difference. They have a constant second difference as long as you're looking at equal length input values. As long as you're looking at a table where the x's go up by the same amount, your second difference will be the same number. And I'll show you some examples with that. All right. Some other ways that you might see the reasoning. All right. You might see the change in the average rate of change. The word change is in there twice. Second difference. So that's constant. The change in the average rate of change. So bear with me. We'll get to some examples. Okay. You might also see the average rate of change is linear, because the average rate of change is a linear pattern. Okay. But you need to know linear functions have the same first difference. Quadratic have the same second difference. So let's look at a table. First of all, do my x's go up by the same amount?
Yes.
Good. So I'm going to find the first difference, because I'm going to check first to see if it's linear. So from 0 to 1, what do I add? 1. From 1 to 4, I add 3. From 4 to 9, I add 5. So is this table showing a linear function? No, because these numbers are not the same. If it was linear, those numbers would have to be the same. All right. So to find the second difference, so if you want to write first difference, that's the first difference. Now the second difference, we see, okay, from 1 to 3, what do I add? 2. From 3 to 5, I add 2. That's the second difference. Is my second difference the same number? Yes. So that means that it's quadratic. So I would say, yes, it's quadratic. Because, and then I could say a few things. I could say, because the second difference is constant. I could say, because the change in the average rate of change, the word change is in there twice. Second to, it's in there twice. They kind of go together. That's constant. Or because you could say the average rate of change is linear. The first difference is your average rate of change. And that follows a linear pattern. 1, 3, 5, 7, 9. So you've got 3 different ways that you could express the reasoning. Okay. So they all mean quadratic. And they could show up in any of those ways on multiple choice. On your first test, you won't have learned enough to see like one of the full FRQs from the AP exam. So you might have a written question where I ask you something like this and you have to give your reasoning. And I would accept any of those reasonings. But on the true FRQ, on the actual AP exam, you don't have any questions where you have to answer this written out. It's all multiple choice. And you'll probably have one that says, is it linear or quadratic? And you'll have linear with 2 different explanations, quadratic with 2. So you need to figure out which one it is and then figure out which explanation is correct. Okay. So let's look at 4. Do my x's increase by the same amount?
Yep.
Thank goodness. All right. Let's do first difference. From -1 to 1. 2. From 1 to 2. From 2 to 2. 0. Is it linear? Nope, because those numbers aren't the same. All right, second difference. From 2 to 1? Minus 1. 1 to 0? Minus 1. Is it quadratic? Yes, it is. So, yes, it is quadratic because, and then I want you to write in whatever explanation you want. Yes, quadratic because, and then fill in your explanation. You could say, because the second differences are constant. You could say, because the change in the average rate of change is constant. Or you could say, because the rate of change is linear. So you got average rate of change, first difference, change in the change. You said the word change twice. Second difference. All right, 3 questions. I want you to, I think there's one linear, one quadratic, and one neither. I'm not 100% sure that there's one of each, but try those. Jalen, number 6.
I say it's linear.
You said it's linear? All right, do you all agree? All right. Because your first difference is -5, right? All right, number 7. Mary, what'd you say? Oh, it's okay. Well, I did tell you that there's probably one of each. So, using process of elimination, which one do you think it is? Neither. So, let's just verify. 3 to 4, you add 1. 4 to 5, you add 1. Oh, 5 to 6, you add 1. Oh, why is it not linear? Because your x values don't go up by the same. I probably tricked some of you. You probably put linear. So the x's go up by the same, or the y's go up by the same, but the x's don't. So this would be like 1 over 12 to 13 would be 1, 1 over 2, 1 over 3, 1 over 4. Because your y's are increasing by 1, your x's are increasing by a different amount. So your rates of change are 1, 1/2, 1/3, 1/4. That's also not going to be quadratic either. All right, so that one is neither. How many of you put linear? Yeah, I gotcha. All right. So, yeah. So watch out for that. Actually, I didn't know that I did that until I started going over it. Because it's been a long time since I made these notes. I will tell you that we are in a much better place than we were last year. It's going so much better. All right, so also from tables, you can know if a function is concave up or concave down. Now, if it's linear, it's not going to be either. Linear is a straight line, so it doesn't make a frown or a smiley face. Okay? But assuming it's anything else, you can determine if this section of the graph is concave up or concave down. All right, so concave up. Do you all remember what you wrote about the rates of change? So in concave up, the rates of change are doing what? Increasing. So you had a chart a lesson ago that's got the arrows going back and forth. If the rates of change are increasing, it's concave up. So if a function is concave up, the average rates of change will be increasing. Which means the first differences, so your first difference is your average rate of change. Okay, if that number is getting bigger, we say it's concave up. All right. If the function is concave down, the average rates of change will be decreasing. Doesn't really matter what the pattern is, but those numbers are getting smaller. That means it's concave down. So the first differences will be getting smaller. And I do want to add in one other thing to this. All right. So let's go down here to this bottom space. When I say F is, I'm talking about the graph. So F is increasing when the Y values get bigger. So you could be looking at the Y values, which are these numbers right here. Okay, that tells us if the function itself is increasing or decreasing. Is it going up or down? Okay. We could say that F is concave up if the first differences get bigger. So I know there's a lot of vocab, there's a lot of things that are so similar. One thing is increasing, that means this. Okay? Give it, before you just start to blow off this class, you are going to see this over and over. I promise you that when we get to like Unit 3, and we're doing it in Unit 3 with trig, guess what? On the FRQ, there's literally a multiple choice question on the FRQ that says it's like increasing or decreasing. Okay? You will see it so many times that you'll think back to this and you're like, oh, I struggled with that, but oh, it's so easy. Okay? I care about the end. Remember on tests, we're going to practice this. I curve the tests, and you can do test corrections. Okay? I want you to pass the AP exam at the end. I want you to get an A in here. If you try really hard, most of you will get an A. Okay? Because I give you lots of chances. All right. Now, the same thing can be true if it's decreasing. The Y values get smaller. Okay, I'm going to write decreasing up here. And write smaller because makes sense. If it's concave down, the first differences get smaller. All right. So, these questions here, I know I just said concave up, concave down, but I also want us to look to see if F, the graph itself, is increasing or decreasing. All right. So, first of all, let's look at number 8. F is, now we're not going to say it is. When you say F is, or this is F of X, so I'm using F, you're talking about the graph. So you could say the graph is, or you could say F is. Is F increasing or decreasing? It's what? It's decreasing. Why is it decreasing? Yes. It's decreasing because your Y values themselves are getting smaller. Can't spell. Because Y values are decreasing. Okay? So F itself is decreasing because the Y values are getting smaller. Now, is F concave up or concave down? What do we need to calculate before we know that answer? We need to calculate the first differences. So, from 4 to 1, we minus 3. From 1 to negative 1, you minus 2. Negative 1 to negative 2? Okay, so are my first differences getting bigger or are they getting smaller? They're getting bigger. Negative 3 to negative 1 gets bigger. So F is concave up because first differences are increasing. I abbreviated heavily. And that's a lot to write. So that section of the graph looks something like that. That part of the graph somewhere is decreasing and concave up. It's got that sort of shape to it. All right, let's look at number 9. F is F increasing or decreasing? It is increasing because Y values are increasing. Your Y values are 1, 4, 7, 10. To figure out concave up or concave down, we need to figure out the first difference. 1 to 4, 3, 4 to 7, 7 to 10. What can I say about concave up, concave down? It's neither. It's linear. This is a straight line. The first difference is the same. It's a straight line. So F is not concave up or concave down because it's linear. All right, to number 10. Serenity. F is increasing or decreasing? Why?
Because the Y values are increasing.
Yes, because the Y values are increasing. Very good. So F is increasing. I'm not going to write the because we're running out of time. Emily, F. Concave up or concave down? You said it's concave down. Why? Because the first differences are decreasing. So this would be 6, 4, 2. 6, 4, 2. Those numbers are getting smaller. Very good.